Hi guys, this is Mrs. Ullrey, and I'm going to talk to you today about accuracy and precision. So make sure that you have your Digital One notebooks open to this page right here about accuracy and precision. That is slide number 32. So let's begin. For day 7, precision and accuracy, let's start with the definition of what is accuracy. So accuracy is a measurement that is closest to the accepted or true value of the object that is being measured. So for example, a football field is 100 yards. So when we're talking about accuracy, if we're building a new football stadium, then we want the football field to be exactly 100 yards. So when we're talking about accuracy, we're closest to the accepted value, what something should be. Precision is a lot different. Precision is talking about how close a group of measurements are to one another. It is possible to be precise without being accurate. So precision, again, is referring to having multiple measurements of the same relative value. So let's check for our understanding. We have 4 different bullseyes here, and we can see dots representing arrows that have hit the target. And so let's use our different words to describe each one of these scenarios. So if we look at the first one, our goal, if we're talking about accuracy, the accepted value would be hitting the center of the target. That's what we want to do. So if we're accurate, we would be hitting that bullseye. So if we take a look at this first bullseye, we can see that we have our arrows have clustered really close together, but they did not hit that center. So we would say that this is not representing accuracy because we didn't hit the bullseye, but we can say that it is precise because those arrows all hit the same general area on the target. Then if we take a look at the next one, we can see that none of those points, none of those arrows hit near one another, nor did they hit the center of the target. So we would say that this one is neither accurate nor precise. Then if we look at this next one, we can see that we hit that bullseye exactly, and all of those dots are right there in the center of the target together. So this would be a situation where we are both accurate because we hit the center of the bullseye, and precise because all of those bullseye hits are close together. And then finally, if we take a look at our last target, we're pretty close to the center, so I would say that this is accurate, but it's not precise because those target hits aren't as close together as we would see in the previous one. All right, so we're not always going to be shooting arrows at a target. Most of the time in science, we're going to be making measurements. So measurements in length or measurements in mass. And so what we're going to look at is how would you tell if a measurement was accurate or precise? So it says 4 students obtained the following measurements in centimeters for the length of a 12-inch ruler. Each group measured the ruler 4 times. Circle the following statements regarding their measurements that are correct. So what I'd like you to do, pause the video, read through this, and then you're going to use that little circle tool. So there's a little red circle on the side, and you'll use that to circle what you think is the correct answer. If you think that more than one of these statements are true, you're going to copy and paste that circle again. Okay, so let's go through it. And so the true statements would be that Oscar was both accurate and precise. So if we look at Oscar, our accepted value is 30.6 centimeters, and you can see Oscar is pretty darn close to that, 30.5, 30.6, 30.5, 30.5. He's also precise because those measurements are all very similar in value, right? 30.5, 30.5, 30.5. So he actually got the same measurement 3 times. And then his 4th measurement was only off by a 1/10. And then we have one more true statement. Shayna was precise, but not accurate. So if we take a look at Shayna's numbers, they're really close together in value, right? 27.6, 27.8, 0.8, and 27.5. So again, they're only off by like a 1/10 of a centimeter. However, they're not very close, especially compared to these other measurements, to the accepted value of 30. So she's precise because her measurements were close together, but she's not accurate because she was not close to what was accepted. So finally, what I want you to do is test your knowledge of the terms accuracy and precision by filling out this graphic organizer. So along the side, you'll see that you have 4 text boxes, and what I want you to do is drag them into the place that describes the pictures that are shown above. You're only going to use 3 of those 4 text boxes. So pause the video and try that out. Okay, so let's go through those answers and see if you were correct. So if we look at the first bullseye, that one's neither accurate nor precise. The target, they didn't come anywhere close to the center of the target. Each of those arrows are scattered all over the place. They're not close to one another, so they're not going to be precise, and they're not accurate because they're not hitting that center of the target. Our next target only shows precision. So we can see that those arrows hit the target very, very close together. The darts hit the target very, very close together, but they didn't hit the center of the target. So these would have precision because those dart hits are close together, but it would not have accuracy because it didn't hit the center of the bullseye. And then finally, this last one would be both accurate and precise. It's precise because we can see that all of those dart hits are close together, but we would see that it's also accurate because it's hitting the center of the target. So all of those dart hits are close together and they're hitting the bullseye, which would make them both accurate and precise.